All right, welcome to the Explainer. Today we're going to put on our detective hats because we're diving into how simple data, just numbers on a page, can end up solving literal life or death mysteries.
So let's kick things off with the central question, the big mystery that public health officials wrestle with every single day. How do you take this giant ocean of individual health records, all these disconnected facts, and actually turn it into something that saves lives?
You know, like any good detective story, the first step is sizing up the problem. You got to understand what you're up against. And in public health, the culprit, the bad guy, is often totally invisible. A new virus, a hidden environmental risk, you name it.
And the key to cracking this case? It's a powerful tool called health information. Now, don't let the name fool you. This isn't just about spreadsheets and numbers. It's the whole system, the entire process of turning raw data into real, life-saving intelligence.
All right, so where do our public health detectives even start looking for clues? Where does all this data actually come from? Let's get into it.
The detective's toolkit is packed with all sorts of sources, but every investigation really kicks off with a few fundamentals. Think of these as the eyes and ears on the ground for public health.
First up, the census. Now think of this like taking a super detailed photo of the entire population at one specific moment. It's our baseline, our before picture. Without it, you have no idea what normal even looks like, right? You're flying blind.
So if the census is that one big snapshot, then tracking what we call vital events, births, deaths, that's like turning on the video camera. It gives us a moving picture, showing us how the population is shifting and changing in real time. This is how you spot trends as they're happening.
Okay, but here's the thing. A huge pile of clues is, well, it's just a pile. It's pretty much useless until you start organizing it and looking for the patterns hidden inside.
And this is where the magic really happens. All that raw, messy data, it's chaos. But visuals tell a story. They are the tools that let us cut through all that noise and see what's actually going on.
Yeah, exactly. Different charts are like different detective tools, right? Take a bar chart. It's basically a police lineup for data. You can put different groups side by side and immediately see which one stands out from the crowd.
Then you've got something like a line diagram. This is like a detective following a set of footprints. It's perfect for tracking a trend over time to see where the story is actually heading.
And a pie chart? Well, that gives you the big picture at a glance. It shows you how the whole pie is sliced up, revealing each suspect's piece of the action, so to speak.
All right, so we've organized the evidence. We can see the big picture. Now the detective needs to figure out what's typical. What does a normal day look like in this data? We need to create a profile of our average case.
And to do that, we actually have 3 different tools to ask what's typical. You've got the mean, which is just the classic average. Then there's the median, that's the value sitting smack in the middle of the lineup. And finally, the mode, which is simply the value that shows up most often. Each one gives you a slightly different angle on what's at the center of the story.
And this is the detective's map. It's called the normal distribution, or the bell curve. You've definitely seen it before. It shows us what we expect to see, with most of the data clustered right around the average. Why is this so important? Because it lets us spot the outliers, the things that are weird or alarming, almost instantly. Anything that doesn't fit this pattern is a major clue.
So in a normal situation, about 68%, so more than 2/3 of all your data points are going to be huddled pretty close to that average. They fall within what's called one standard deviation. Just think of a standard deviation as one standard step away from the middle. It's a super useful way to mathematically define what's common and what's rare.
Okay, so our detective has found something. A pattern, an outlier, a hot lead. But here's the million-dollar question. Is it a real clue, or is it just random chance? A coincidence?
Well, to figure that out, we use this really clever process called a significance test. The logic is kind of brilliant. You start by assuming your hunch is wrong, that there's no real connection. Then, you look at your evidence, and you calculate the odds of seeing what you saw if it was all just random luck. And if those odds are super, super tiny, then you can confidently say, nope, my first assumption was wrong, this thing I found is real.
Let's look at a real-world example, like this vaccine trial. Okay, so vaccine B seems to have a lower infection rate. But hey, maybe the people who got it were just lucky, right? This is where a statistical tool, in this case, a chi-square test, comes in. It does the math for us, and the test proves the difference is so big, it's highly unlikely to be just random chance. That means we can be confident that vaccine B is genuinely more effective. Case closed.
And that really brings us to the whole point of this entire process. It's like this quote says, it's not just about the numbers themselves. It's about taking that information, mixing it with experience, and turning it into real intelligence that can actually protect people.
So yeah, data is literally the lifeblood of public health. The next time you see a headline with some new health statistic, try to remember the detective story behind it. Think about the clues, the patterns, and the case they had to solve to bring you that number. And then ask yourself, what story is the data all around me trying to tell?